I wanted to start by going over the formulas for some of the measures of dispersion we talked about in the last video. I wanted to go over the formulas for population and sample variance and for population and sample standard deviation. These formulas use the symbols that we went over in the last video. So I'll remind you what the symbols stand for. This is the formula for a population variance. It's x minus mu, this Greek symbol that looks sort of like a U. It's actually the sum of that squared over capital N. Now what is this formula saying? The x minus mu means a data value minus the population mean. Remember that this mu symbol right here stands for the mean of a population. So what this formula is saying is to subtract each data value, each x, by the population mean, and then square the answer. So that's the step that we did when we subtracted each value by the mean and we squared all the answers. This right here is a summation symbol. What it's saying is for us to add all of the squared answers. And when we calculated the population variance in the last video, one of the steps that we did was adding all of the squared answers. What this n on the bottom is saying is to divide the total of the squared deviations by the population size, by the number of people in the population. The capital N stands for the number of people in the population. So when we divide the total of the squared deviations, which we have on top, by the population size on the bottom, we get the average or the mean of the squared deviations, which is the population variance. Let's now talk about the formula for the sample variance. It's a similar formula, but some of the symbols are a little bit different. X still means an individual data value. It's x minus x bar squared over lowercase n. So notice how this symbol has changed to an x bar, and this symbol right here, this uppercase n, has changed to a lowercase n. Now why has it changed? Well, x bar is a symbol for a sample mean. When you calculate a sample variance, you're subtracting each data value by the sample mean, by the mean of the sample. So the mean is an x bar instead of a mu. And when you calculate a sample variance, you're dividing the total of the squared deviations, which is up here, by the number of people in the sample. Actually, I'm sorry, you don't divide it by the number of people in the sample. You divide it by the number of people in the sample minus 1, because the sample variance has an adjusted formula in which you don't divide by the number of people in the sample, you divide by 1 less than the number of people in the sample. So this formula is telling us to subtract each data value by the sample mean and square the answer, square each of the answers, and then add all of the squared answers, and then divide the total that you get on top by 1 less than the number of people in the sample. Remember, the lowercase n is the number of people in the sample, and 1 less than that number is n minus 1. Now what about the formula for population standard deviation? I'm sorry, I should have said population variance and no, actually, I did write it out correctly. Sorry. I thought I made a mistake, but I didn't. Remember that the population standard deviation is just the square root of the population variance. If you take the variance and go one step further and get the square root, you get the standard deviation. So, to get the formula for the population standard deviation, we just take the variance formula, we take the population variance formula, and put it under the square root sign, like this. So if we take the population variance formula and put it under the square root sign, we get the formula for population standard deviation. What about the formula for sample standard deviation? Well, the sample standard deviation is the square root of the sample variance. So we just take the sample variance formula and put it under the square root sign. And there's our formula. What this formula is saying is that if you want the sample standard deviation, just take the sample variance and find the square root of the sample variance, and that equals the sample standard deviation. What you have to do to get the sample standard deviation is use this formula to calculate the sample variance, and then go one step further and get the square root of the sample variance. And these are the four formulas that I wanted to cover.